Hi everyone, welcome back to Operations Research. This is our third course and we're talking about theory. Today we're going to give you again case studies, but unlike for algorithms or modeling, there we were doing case studies to solve real problems. Here, as we are talking about theories, theories are for us to build better models or better algorithms that may better solve real problems. So we're going to give you several examples about model building, in particular in other fields. So we're going to show you how our theories may be applied. You learned a lot of theories, right? You learned about LP duality. You learned about network flows. You learned about nonlinearities. You learned about convexity, a lot of things, KKT condition, duality, blah, blah, blah. All those things are used to develop models in many fields, in electrical engineering, in computer science, in economics, and so on and so on and so on. In fact, one very good example or very good story is that we all know George Danzig. George Danzig is the inventor of the simplex method. So many people typically say it is George Danzig that started the whole fields of operations research. So as some kind of father of operations research, his doctoral degree is actually about statistics in UC Berkeley. Okay? Of course, at that time, there was no such field of operations research, but that somehow directly tells us that optimization techniques, algorithms, theories can help people developing theories in statistics. Okay? So for today, we're going to use statistics and machine learning as two examples to show you how operations research may help us build, construct, derive models in these two fields. Okay? So our examples will be focusing on nonlinear programming. So I feel sad because I have no time to show you how linear programming and integer programming theories are applied in many other fields. That are also fascinating. But for today, I'm going to talk about nonlinear programming theories. There are several reasons. So first, everybody wants to learn statistics and data mining and machine learning now because they are useful. And also, according to my personal teaching experience, nonlinear programming theories, those KKT, Lagrange, whatever things, are a little bit complicated for typical beginners. So that's why I want to use these examples to somehow strengthen your understanding about nonlinear programming theories. So that's my plan for today.